Hey guys, my name is Sibusiso, but you can also call me Coach Boo. Welcome to the Mathsbuddies channel. In today's video, I'm going to be sharing with you a method on how you can solve 2D and 3D trigonometric applications. Now this method, it works whether you are a grade 11 or a grade 12 learner. So please make sure that you stick and watch the video if you know that you are a grade 11 or even if you know that you are a grade 12. Alright, so also lastly, if you are a new viewer and you're a returning one and you find yourself with any topic that you're struggling with, please be sure that you leave that in this video's comments so I can be able to generate a video for you. And also don't forget to subscribe so that you won't miss when another video gets uploaded. So without wasting any further time, we're going to go straight into the question. Now in this question here, we're having a 2D trigonometric application here. And as you can see here in the questions, you can see that we need to prove some sides here, right, using the trigonometry. Right, now the idea of 2D and 3D trigonometry is this, right? So the method you can follow, or the method that you're supposed to follow when you're doing anything, is this. So let's say method before we can even go into the question, right? So the method number one is to always make sure that you identify non-right angles triangle. So I'll call them non-RHS, and identify the right angle triangle. So I'll just call them RHS, right? Now the reason you want to do this is because when you identify a right angle triangle, right, you have formulas that you can do to basically calculate whatever that you want to calculate there. For example, if you have a right angle triangle and then you want to calculate the side or sides, right, we know that you can apply SOHCAHTOA. Alright, that's the first thing that you need to know, right? So this will mean that, for example, if let's say I have a triangle, I'll just do a quick triangle, and then it's 90 there, and then I have x here, but I want to find this. So the only thing I know is if I have an angle here called theta, I'll just say tan theta. It is that side that I want to find over x, and basically it means I can write that side as x tan theta, right? So hence now when it's a right angle triangle, always make sure that when you want to find the side, you use SOHCAHTOA, right? So let's say now so this is the same with angle actually. So if you have a side and angle, so let me say angle and side, you can use SOHCAHTOA to calculate all that, right? And then now if you want to find an area is going to be half times base, right, times the perpendicular height. So these are the formulas that are going to be using to basically calculate side angles and area, right? And then now on the other hand, which is on the non-right angle triangle, so these will be triangles that one have 90, right? So this non-right angle triangle, if now you want to find your side, right, if you want to find the side, it depends on the information that you have, right? So based on the information that you have, you can use a sine rule, right, or you can use a cosine rule. Now in these two rules you can find both angle and sides, right? And then on the last part, if you want to find an area, and then we know that we're going to apply an area rule, right? So now that we have this, I'm going to be reading this question, and then I'm going to be showing you how to know which part to use, right? Because it's very important for you to also understand that. So let's go ahead and read the instruction above. So the question goes as follows. In the circle below, PR is the diameter of the circle passing through P, Q, and R. S is a point outside of the circle. RS and PS are drawn. PS is X, PRS is theta, RPS is beta, and PRQ is alpha. Alright, so now basically here, as you can see here, we are given our information, but then here we were told that PR is a diameter. Now the first thing, before we can even go there, the first thing that we need to do is we need to work with what it means if PR is a diameter. Now in grade 12 in Euclidean geometry, whenever you have a diameter, an angle subtended by a diameter in a circle, it is 90. So this basically means now here we were not told one thing, about this diagram, and that thing was what? It was Q. So this then means now angle Q here, we know that it's going to be 90, right? Because of PR being a diameter, and then PQR being an angle subtended by that diameter. All right, now let's go ahead now and look into our question. Now our question says, let's prove that PR is equals to x sine theta plus beta over sine theta, right? So now here, what is happening? Here we want to find the length of PR, which is the diameter. Now the easy way or the quicker way to do all that, it is always you always need to make sure that you look at the triangles where PR is located, right? Now when I'm looking at PR, I can see that PR is in triangle PQR and also in triangle PRS, right? Now if that is the case, then this then means now, okay, I know that PR is both in PQR and PRS. Now the next question that I need to ask myself is this: between these two triangles, which triangle has more information? Right now, as you can see here, we can see that PRS has what? More information. So this then means now if I want to calculate my PR, I need to focus on triangle PRS. Right, now looking at PRS, what is it that I have there? Right, I can see here I have an angle theta, and this angle has each side, right? And then now I want to find PR, so it means I must have what? I must at least know how to find this side here, or this angle here. Now by the looks of this, you can see that here the only way I can find PR is if I apply what? A sine rule, because the sine rule says in order for you to have that, you must have a non-right angle triangle, which is PRS, and secondly you must have an angle with a side facing it, facing that, and thirdly you must know how to find the other side, or when you're looking at the second side and its angle that it has subtended, they must be at least one information. For example, in this case, we know that R1 has X, that is fine, and then now I want to find PR, but then now when I'm looking at X, when I'm looking at angle S, I don't have angle S, but I can calculate angle S. So this means now this is enough for me to apply what? A sine rule. So now here, this means now if I want to calculate PR, what I'm going to do is first I need to find angle S. So I'll say first angle S is going to be 180 minus angle P1 minus angle R1, right? So that is interior angles, that is of a triangle, right? Of a triangle. So this then means now I have my angle S as 180 minus theta minus beta, right? So if I want to simplify that, I can say it is 180 minus theta plus beta. So I took out the common factor there to write it and make it look like an reduction angle. Alright, now from there I know now that I do have my angle S, and so now I want to calculate PR. So I'm going to apply what? A sine rule, as you have seen there. So I'll say therefore PR over sine S is equals to PS over sine. Now this is going to be PRS. Please don't make the mistake of saying sine R, because it is not sine R, because R is divided to R1 and R2. Alright, now PR, I can see here by looking at this, PR is going to be sine S times PS over sine PRS. Alright, now the only thing that I do now is, because of I've seen my PR, I know where's angle S, where is PS, and what is PRS. All I need to do now is to substitute, right? So substituting, this is going to be sine 180 minus theta plus beta, and then times PS is going to be X over sine, and then PRS is going to be theta. Now when I'm simplifying this, I will get 180, I'll look at the top, sine of 180 minus theta plus beta. So this part in bracket is seen as one angle, so I can call it A, for example. Then this will be like sine 180 minus A. Now I know 180 minus an angle that belongs in the second quadrant, and sine is positive there. So this will mean now my final reduced angle will be sine theta plus beta, right? And then to say times x over sine theta. And as you can see, this answer is the same as that. If you want to, you can either write it this way, or you can just write it the way that they wanted it. All right, let's go ahead and look into the second one. Now the second one, it says now we need to prove that QR is that, right? So we know this now, right? Let me put that. We know that, right? And then now we know this. You see that? So now they're saying that we need to calculate QR. Now looking at this, you can see that, okay, here I have PR and I have QR here. So which means QR belongs in triangle PQR, because that's the first thing that is very important to identify in which triangle are you going to use to calculate your side. Right here we can see that we're looking at triangle PQR, right? So if I'm looking at a triangle PQR, then this means now if I want to calculate my angle, I do have PR already, right? What else do I have? I have an angle, and then I want to find this. So this means now PR, I can see it is my hypotenuse. PR, if I'm looking at alpha as my reference angle, PR becomes my hypotenuse, right? And then QP becomes my opposite, and then of course QR is going to be what? It's going to be my adjacent, right? Now I know that because I'm using a right angle triangle, the only way I could solve this is by what? Is by SOHCAHTOA. Alright, so let's go ahead and do that. So now basically I'm going to say now I want to find QR. So I'll say I have an adjacent. Let me just mark here. I'm going to look at what I have. So I know that I want to find the adjacent, but I have an hypotenuse. So according to SOHCAHTOA, the trig ratio that has both adjacent and hypotenuse is what? It is cos, right? So then from there, what I'm going to do is let me highlight that, cos. So therefore what I will do is I will say cos, right? And then I'll say PRQ, because that's what alpha is equals to adjacent QR over hypotenuse, which is PR, right? And then from here I will see that now here I get my QR as PR times cos PRQ. All right, and then from here I'm just going to see substitute what I have here, and that is going to be basically my answer. Now here I can see that PR, right? PR, it is x times sine theta plus beta over sine theta. Now this multiplies with cos PRQ. It is what? It is alpha, and therefore if I want to write it that way, it would be x cos alpha times sine theta plus beta over sine theta. And that is all for this video. So if you like the video, please make sure that you leave a comment, tell me what you think about it, like it, share with your friends so that they can also learn how to basically approach these type of questions. Now this is basically applied even when you're talking about the grade 12, sorry, the grade 11 2D and 3D trigonometry application. And that's all for this video, and I'm gonna see you on to the next one. Cheers.